Hello students, this is Ms. Dalton and today's video is on quadratic function basics. Our goals are we want to analyze quadratic functions in vertex form. We're going to look at the vertex, the maximum, minimum, axis of symmetry, domain and range, and intervals of increase or decrease. You're also going to analyze quadratic functions and graph them without a graphing calculator. So this is going to make more sense to you if you do not use a calculator in the beginning, and then once you understand what the graphing calculator is actually doing when they graph a quadratic, then you'll be able to, it'll make more sense when you use the calculator. Okay, so first let's just look at quadratic functions and what the graph of a quadratic function looks like. First of all, it is called a parabola. A parabola can open up or down, and if the parabola opens up, the lowest point is called the vertex, which is also called the minimum of the graph. If it opens down, the vertex is the highest point, which is what and again, it is still called the vertex, but it is the maximum of the graph. Note that if the parabola opens left or right, it is not a function, and in Algebra 2 we won't look at those right now, but you will see them at a later point. Alright, so the other thing that you need to know is that parabolas are symmetric. So we have what's called the axis of symmetry. If you draw a line straight down the middle of the parabola, you would be able to fold that parabola in half. It would be symmetric on each side. We call this the axis of symmetry, and in some cases it is called the line of symmetry. Axis of symmetry, line of symmetry, it is meaning the same thing. It is what cuts that parabola into two symmetric pieces. If you graph one side of the parabola, you can reflect it over the axis of symmetry to graph the other side. So this will become important when you are building the graph. Once you get one point on one side, then it will have a symmetrical point on the other side just by reflecting it over the axis of symmetry. So let's first look at the quadratic parent function. So if we build this quadratic parent function, what we're going to do is just think about if you were just to plug in values. So let's look at a few values. If I plug in a -3 for x, when you square a -3, you get +9. So the y value would be +9. If I do -2, then you would square the -2, and when you square a -2, you're going to get 4. If I take -1 and I square that, then I get +1. If I have 0 squared, that's going to give you 0. And then if I start looking at the positives, 1 squared will give me the same thing as -1 squared, which is +1. So you can see that we're starting to get symmetric on each side. If I go to 2, well, it's going to be the same thing as -2, because you can see that, okay, we do have symmetrical pieces now. So let's go ahead and look at what the quadratic parent function looks like. So we've got the vertex. The vertex is going to be at 0, 0. And then we have 1, +1, and we have -1, +1. Sorry, these dots keep disappearing. So let me try and dot them in like this. And then if we have -2, +4 would be about right here. And then a symmetrical piece on the other side, we're going to have a symmetrical point over here. So when I draw my quadratic parent function, I'm going to try and draw it as best I can just with my stylus. It's kind of hard to do on a screen. But you can see that this is the quadratic parent function and this is what it looks like. Okay, the vertex form of a quadratic function is y equals a parenthesis x minus h squared plus k. So this should look familiar to you. We're dealing with vertex form for several functions. We've looked at the absolute value function, and now we're looking at quadratic. You can see that each of these functions still have the same transformations. The a is going to be a vertical stretch or compression. The h is going to be a horizontal shift left or right, and the k is going to be a vertical shift up or down. The parabola will open up when the a value is positive. Okay, so when you look at that a value being positive, just recognize that it will open up. The parabola will open down when the a value is negative. And a can never equal 0. Think of it this way. If I substituted in a 0 right here for a, then that would make this whole piece 0, and we would end up with a line. We would not end up with a parabola. All right, the other thing that you want to look at, the vertex form of a quadratic, the vertex is still like it was in the absolute value. The vertex is going to be your hk. The axis of symmetry is at x equals h. On either side of the graph, or of the vertex, the graph is either increasing or decreasing. So remember those key vocabulary words. Increasing means that it is going up from left to right, and then decreasing means it's going down from left to right. Okay, so we're going to look at this first example. We're going to graph y equals -1/4 times x plus 2 quantity squared plus 5. So you can already start to think, okay, what this is going to look like. It's going to be reflected over the x-axis, which means it's going to open down. 1/4 means it's been vertically compressed. It's moved to the left 2 and up 5. So we're going to graph 3 points. We're going to name the axis of symmetry and the vertex, and we're going to name the transformations compared to the parent function y equals x squared. So first off, we're going to get the axis of symmetry. Well, remember, the axis of symmetry is just x equals h. Since h is -2, then the axis of symmetry is the line x equals -2, and this is what it's going to look like. Then the vertex is at -2, +5, so we're going to graph that next. And then it says to graph 3 points, so we need to graph one other point and do the symmetric. Now, I'm going to choose, what you want to do for this is you want to choose an x value that is on one side of the axis of symmetry and substitute it into the equation to find the y value. In this particular example, I chose x equals 0 because x equals 0 is on the right side of that axis of symmetry. So when I plug in 0 for x, I get y equals -1/4, 0 plus 2, quantity squared, and then plus 5. Okay? After I simplify it, then I will get y equals -1/4. 0 plus 2 is 2, and 2 squared, and then plus 5. And so that's going to come out to be y equals 4. So another point on this graph is 0, 4. And then if we use the symmetrical, so if we reflect it over the axis of symmetry, then the other point is going to be -4, 4. And now what you'd want to do is you'd want to go ahead and draw your parabola by connecting those 3 points. And so it would look something like this. Okay, and then the last thing is to name the transformations compared to the parent function. And so the negative is going to reflect over the x-axis. We're also going to have a vertical compression. by 1/4. And then we will also have a horizontal shift to the left, 2, and we will have a shift up, 5. Okay, that is the end of today's video. Make sure that you're submitting your Google form, so hit next and then answer the questions.